What's up, everybody? How we doing?
Good. I'm a little bit confused about some of the questions on the study guide.
On the study guide, can you link the study guide to me? 'Cause I haven't actually even looked at it.
Yes.
Please, thank you. Yeah,
Yeah, I got it right here. I'm about to DM it to you right now.
cool. Don't worry about that. That's fine. Nothing wrong. All right. Let me take a look at this real quick. Okay. Okay. So you were confused about some of the questions on the study guide?
Yeah.
Which questions were
Yeah.
you confused about?
Uh, just making sure I understand this question correct. The one that says visualize the words with the greatest difference in counts between good and bad. Is that basically saying to get the word counts, visualize it between the good and bad reviews? Is that basically what that's saying?
Yeah,
If I'm right.
yeah, and
Okay.
kind of see what the difference is between like the words being said in good reviews versus the words being said in bad reviews.
Okay. Did that correct. And then also there's another question that says visualize the most common word counts. Isn't that what we just did now? Or is this asking to like combine the good and bad and then get the word count of that?
That depends. That question is entirely contextual. What is it exactly that you're trying to do? Can you visualize, given any set of words, the word count, or the
Yeah.
visualize the most common word counts?
Yeah. I mean, I did it for the good and bad. That's basically what I did.
Yeah. Okay. Well, then that's the same thing, basically.
Okay.
Yeah.
Okay.
Try not to
I'm
think
just
too
double
much about it.
checking. I'm already thinking too much about it.
You're overthinking, man. Yeah. So if you can visualize any one, then you can visualize any other, right? That's
Mhm.
essentially what it's talking about. All
And then
right.
it
Cool.
also says try different visualizations. The only one I've really done is like Squarify, and then the one we did today with like we made like a line graph for the what's it called? To figure out how many labels we're gonna have. We made like that graph.
Yeah. Okay.
That's pretty much all the visualizations we've done.
Yeah. Hang on. Not even gonna lie, when I did this, the only real visualizations I did were word clouds. That's pretty much all I did. The idea is, can you figure out um, a way to visualize, the words most, yeah, the most common words, right? At the end of the day, how you choose to do that is entirely up to you. And there's a ton of ways to do it. I recommend going online and looking it up, right? There's like a ton of different ways. All right. Um, yeah, so I was kind of wanting to get a feel for where everybody's at. Like, how do you guys feel about NLP? What are some of the things that you guys kind of feel comfortable with versus some of the things that maybe you don't feel so comfortable with? Open forum here. Anybody can talk.
I feel like I'm having a lot of hard time understanding this whole concept about NLP. I understand a few things, but I feel like I've been kind of behind in everything. It was like I kept going back and rewatching other instructors. I found Bruna to be kind of helpful to me because I feel like he was really breaking everything down. But I don't know. I don't really feel good about tomorrow's sprint challenge, to be honest. But
Okay. Okay. So is it kind of the overarching what is NLP, or is it the why do we need NLP?
um, like, what is NLP? Like, I understand stuff like like we have to clean everything up. Yeah. Also, I don't know the whole thing, the whole concept of it is just I don't know. I still don't understand. You know.
Okay. I can try to talk a little bit about the high level concept of NLP to maybe help make some of that make some sense to you. Also, the example that I have is I went online and I took some data off the internet, right? And we're going to do NLP on it for a specific reason, right? And I'm going to kind of talk about that in context. Maybe that'll help make some sense. Anybody else? Anything in particular like involving these NLP processes that maybe you are not so comfortable with?
I feel like I have a good understanding of like the foundations of tokenization and vectorization and like why we do those. And then I feel like I have a kind of a gap where that's applied to something like LDA, where like we're using things like the corpus and something called ID to word, and like those concepts kind of didn't. I couldn't. Yeah, I talked to my TL a couple times, and it's still not fully meshing how that the like tokens and vectorizations map to the modeling. Like the interpretation of the model actually made sense because it felt familiar from like unit 2.
Mm-hmm.
But yeah, that's some of my thoughts.
Gotcha.
Oh, I feel like I don't know what was just like a building block and what is actually necessary to apply to the NLP, you know? Like what do we truly need to do to complete the model? Do we actually have to, oh my gosh, sorry, cat, just like move my whole desk. What we actually, because it seems like some of the steps are incorporated in some of the other things that we were learning, you know? Like, do we have to tokenize or will one of the steps that we're using tokenize for us? You know?
Yeah, actually, I think that more or less depends. If I'm understanding correctly, with the topic modeling, Gensum does not tokenize where you have to develop a tokenizer, where you have to tokenize your documents.
I mean, I would understand that I would have to tokenize or vectorize because all of a sudden you'd get an error and be like, oh, okay, I should probably do this. I understand that much.
Mhm.
But understanding like what processes would use what and when, like I feel like I just end up wasting a bunch of time doing steps that are already incorporated in something.
Okay. What kind of steps? Can you be a little bit more specific?
Like
so
the
that we
token,
can
like the
narrow-
tokenizer and stuff like that.
Okay.
Because like I literally in my homework, I've tokenized by hand. I've tokenized using the my brain is broken. We're at that time of night.
Yeah. So
Using-
tokenization, I should be pretty clear about this. Tokenization can be done in a lot of different ways. You can do it by character, by sentence, or I'm sorry, by character, by word, by sentence, right? And then you can also do it in 2-word chunks, 3-word chunks, 4-word chunks, 5-word chunks. There's no end to the different ways that you can tokenize data, right? I think he probably touched on engrams, right? You guys remember hearing about engrams? Okay. Engrams take into the power, into the nth power of space, right? Whenever you do them, because it takes chunks of the text, right? And you can do it by character, by word, by sentence, or even by paragraph. I've seen it done. So there is a lot of different ways to tokenize. Well, what is it essentially accomplishing? Can you tell me that? What does tokenization do?
It's allowing the computer to, well, it allows us a step to vectorize so you have bite-sized portions so it can learn a little bit better, learn in a more formatted fashion.
Right? Learn in some structured kind of way. We're providing structure, right? Text inherently can be very dirty or it's very ambiguous, right? We're providing structure to the text, getting rid of words that have little to no value, right? That's all part of tokenization. And so how you tokenize really truly depends on the context of your problem, right? What are you trying to solve? And you'll hear me say that a lot when it comes to NLP, but that's like super important. You need to understand what your problem is, right? Because there's a lot of different types of NLP and not all of which are going to be useful for every problem. Okay. There's going to be times, hint, 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 wink, wink, in the future when you need to do character tokenization, right? Because you're training a model to write characters, right? It's trying to predict text. Or you might be doing it word by word, where you're doing more classification type models, and you need the model to disambiguate text, right? Try to figure out what text belongs where. And that also sort of applies to LDA topic modeling, right? Trying to figure out, this document, what is it talking about? What is the overarching topic here, right? And all the various methods of doing that. So yeah, I think that's definitely a good point. But at the end of the day, what it really comes down to is understanding your problem. For the purposes of like this sprint, you're really focused on word by word tokenization. Okay. And yeah, I think we'll talk about the steps involved there, because I think they're a good set of steps to follow all the time.
So tomorrow will we have to like specifically, will there be something that we have to specifically take out via a tokenizer or a stop word?
I can't tell you that for certain,
Okay.
honestly, because I don't have the sprint challenge with me. But as I recall, yeah, that was a step that I performed. So I would expect to do that. I would expect that we would need you to be able to demonstrate that you're able to filter out stop words, add stop
I guess
words.
that's a better question. Are we just using the predetermined stop
Yeah.
words?
Well, I would expect you guys to be able to add stop words. So that's something that I think you should know.
Okay.
Because depending on the problem, you might need to take out additional words, right? For instance, if you're doing coffee shop reviews, coffee and shop are not very useful words, are they? Everything's about a coffee shop. What value does that word have, right? If you're doing job listings for data science, job, data, and science are probably useless words, right? But they're not stop words. You have to add those. So yeah, it's all contextual, right? You need to understand the process. But depending on the package that you're using, which we're teaching you Spatie sets, kind of what we're going to be doing.
I'm sorry, will they be clear about that, what we have to use for tokenization? Because today's lecture, we didn't use any Spatie. We use this
GenSim and NLTK, yeah.
Like simple process per process from GenSim, and stop words, it was all tokenization we did, really. Like, will they be like more clear what kind of tokenization they want us to use, or they want like just better result? I don't know.
Yeah, hang on.
That's literally what I was trying to ask. I just couldn't.
I know that the instructions are going to be the instructions are specific about what you'll use and where you'll use it. For tokenization, you should be using Spatie, right? Spatie makes tokenization super easy. Doing it in any other package, the reason why Spatie was invented is because it's more difficult than every other package, right? That's kind of Spatie's niche. That being said, topic modeling, I think most people learned it in GenSim and NLTK, but I'm pretty sure there's other ways to do it. I'll get back to you on that one because I'm not a savant with topic modeling yet. But yeah, I think everything on the instructions should be pretty clear, pretty concise about what you're using. They'll probably even provide you a little bit of boilerplate code for some of the things that we don't expect you to have memorized or be very, very easy without several weeks to study, right? So yeah, I hope that answers your question.
I wanted to clarify, I understand what tokens are, essentially like why we need them. Is tokenization a broad, general sort of term that can mean a lot of different things and have a lot of different methods to it? Is it essentially just breaking up, like we break up with our eyes with white space, which word's which? Do you end up with and what is the term for the thing that is the in unique words list, basically? Does that make sense?
Yeah. The actual set of words.
Right.
That is your dictionary.
Okay. And the corpus is everything.
The corpus is your entire, all of your bodies of text. A corpus is comprised of docs. Docs are comprised of tokens.
Mm-hmm. And the lemmatization is a kind of tokenization that's more specific.
It's an additional step where you're converting all the any token that is a word. We should be clear, this is a word-based function, right? That breaks the word down to its base form.
Yeah. Okay.
Yeah, it's not a token specific thing because again, tokens can be characters, they can be whole sentences.
Right.
But yeah, lemma is the base form of a word. So you do that to a word token. It's an additional step.
Yeah.
Cool. Yeah, good clarification on that. All right. Yeah, so I've got some a pretty basic example of like the bulk of what your sprint challenge is going to be. That I need to pull up real quick because I don't have it up yet. But it's like a lot of what you're going to be doing is, again, that tokenization, normalization, pre-processing your text, getting it prepared, and then doing document classification, right? That's going to be the overarching theme here. And that'll be pretty obvious once you find out what your problem is, right? That said, I wanted to make sure that we kind of covered at least one of the possible ways of doing it. And I chose the shortest possible way because it's valid, very, very, very valid, okay? Which is spaCy embedding, okay? Kind of using that pre-trained spaCy model to give us some word embeddings. So let's, let me start on my JupyterLab here. Give me 1 second, y'all. While I'm pulling this up, has anyone had any issues getting their JupyterLab to work? Package dependencies, anything like that, that could be an issue before the sprint challenge? Because I feel like we don't ask that question enough, and then sprint challenge day comes and they're like, my environment's broke.
Are we just using the environment that we created at the beginning of the week?
Yeah.
We just,
So somebody says, has anyone encountered any problems that they just neglected to tell anybody for some reason? Because now's the time to get that out, get that sorted.
It's not exactly an environment problem, but did you experience it all? I brought up during lecture today where when you do that display method, it makes you not able to see all the icons on your toolbar in JupyterLab. I don't know if you know what I mean.
The display method, you're talking about the IPython display?
I think so.
Where you're showing a picture? Like displaying a picture, displaying a video, something like that?
No. It was like a specific, we imported a package to display LDA models like visually pretty well. And when we use that,
for LDA models? I don't think so. No.
Then the tab, it just doesn't.
Yeah, the toolbar kind of disappears.
It sounds like an extension for JupyterLab is needed to work.
I don't use labs at all. I just open up the notebooks via the Anaconda navigator. You don't get as cool of visualizations. You know how like sometimes some of the words will be highlighted differently based off of the imports and stuff like that, but it seems to run faster, just work better.
That's interesting.
Yeah.
Okay. I don't know that anyone has actually used the Anaconda Navigator as their IDE before. Are you able to modify stuff in?
So what happens is it pulls up.
Navigator?
Yeah. What happens is it pulls up like your. It'll pull up actually your entire directory, and then you can just navigate it like you would, like your My Computer.
Yeah. So that's what Lab gives you to. As opposed to like Jupyter Notebooks where it's kind of got a weird interface. With Lab, you have like the pane that most people are used to.
Yeah, like the Colab pane and stuff like that.
Okay, well actually I'm going to get into it now. We're going to kind of work through this notebook a little bit. But I appreciate the concern. I'm going to try to implement some more high level explanation for what we're doing and kind of why we're doing it, right? So let's go ahead and get started.
I'd appreciate context in my Python isn't strong, so when we're doing functions or using anything from any packages, making explicit what part of the package everything belongs to helps me a lot too. Thanks.
Okay, you got it. I didn't end up not using that, so we'll just take it out. Okay, cool. So I went online and I found some real life Amazon reviews. All right. In a very broad category, there was over 100,000, close to 200,000 reviews in this category for this JSON dump. Okay. Which, spoiler alert, I didn't use all of them because my computer would have taken hours to process all that text. I ran it for 15 minutes and I got 2,000 out of 137,000. Okay. So I wasn't going to wait for that. But so here's some real life data, right? Let's see what we can do with it. Now we have these reviews, and all that really comes, this is everything that comes in the review JSONs, right? So I know whatever these things are, I think this is like whether or not something was helpful. This is the rating 1 through 5. Actually, I think 0 through 5. No, it's 1 through 5. For overall, review text is the body of the text itself. And then we have time, reviewer ID, name, summary, and this Unix time. So these things right off the bat don't seem like they're going to be very useful for me in context here, because I've decided what I want to do is try to predict what I want to classify is I want to classify each of these reviews and try to predict if it's going to be what rating it's going to be. Right. So this is kind of my problem. I'm defining my problem because I need to know what it is that I need to accomplish in order to understand how I need to proceed. Right. Is everybody tracking that so far? So everything here is pretty self-explanatory. We're going to import pandas and NumPy, and just in case we need it. We're definitely going to be using Spacy for this. And I know that I want to start with a random forest classifier, right? So this is going to be it's a classification problem, so I need a classifier, right? Pandas and Spacy, very basic, right? Not a whole lot going on right now. Keeping it simple, right? The next thing that I need to do is kind of get rid, or rather, I wanted to make all these columns lowercase because I noticed that they were camel cased as they came from JSON, just to make life a little bit easier on myself. And then I pull out one of the reviews at random so I can kind of see what state the text is in, right? Text can, these reviews can come in a lot of forms. They could be, if they're scraped, they probably have like HTML tags, right? It's a good idea to get familiar with the body of your text and what it looks like. So I see here that really we just have alternate casing, a couple of escaped characters, right? It looks like these apostrophes and stuff like that have been escaped. But other than that, it's pretty standard text, and that's really good. That means cleaning is going to be super easy, right? We got some parentheses and stuff like that, which is going to be handled by Spacy tokenization, so we don't even have to worry about this, right? And I'll show you what that means later. All right, so we don't need all the columns, right? I've determined that pretty much all I need are these two, yeah, for the purposes of solving my problem. So I can get rid of all these others. So I just basically say that the data frame is equal to the data frame, these two data frames copied, right? So overriding the original DF with just these two columns. All right, and then I'm coming through here. Now I want to define, okay, remember back at Unit 2, and before you do a classification problem, it helps to figure out what your target class looks like, right? We have to set this up so to make training a model as easy as possible. Remember imbalanced classes? I wanted to figure out what the spread of my classes was. Turns out it's overwhelmingly 5 out of 5, right? So very imbalanced from the start. If I was trying a multi-class classification problem, this would be very difficult to do. I would have to oversample and stratify and do all kinds of craziness, right? To try to make sure that I get enough of both class to be able to train a model effectively. But looking at this, I said, okay, I got about 63.4%, but 4 out of 5 is 21, and then about 8, and it's pretty close to 10. Okay, so it looks like, remember that 70-30 split kind of defines, that's the upper limit of balanced, right? We don't really want to go beyond that. I said, okay, I think if I change my problem into is 5 out of 5 or is not 5 out of 5, then maybe if I combine all of these scores into one class, this will be a little bit more balanced. And I did find that, yeah, not 5 comprised nearly 40% of my class. So I said, okay, I'll just change the problem to be is 5 out of 5 or is not 5 out of 5. This is a common theme for just about anything, okay? Computer vision. This is very typically what happens, right? You train a model not to identify all types of fruit, but to say is a banana or is not a banana, right? That's where you start, okay? Training a model to predict the actual rating is very possible, but much more complex and in-depth. For MVP, I want to start with the simplest problem that I can just throw a model at and get results, right? This is the process, right? You would iterate from here to then trying to incorporate multi-class classification, right? given that we have imbalanced classes. Now, if all of these were balanced, it wouldn't be an issue. I could just throw a multi-class problem or model at it and it'd be fine. But because it's imbalanced, that would require a lot more work. Okay, so now that I'm done with my justifications for changing my problem, we can move on to how did I get started. So I do my target split. All right, I'm creating this is 5. It's going to be 1 for is a 5 out of 5 and 0 if it is not a 5 out of 5 rating. Okay. Now, first thing I want to do is set up a test case. Right. The whole process that I'm going to do everything that I want to do on one problem first. Right. I've got 137,000. Running that's going to take a long time. I already know this. So let me iron out my process on one case before I do it to everything. All right, so that's what I start with. I know I'm going to need this. This is the web model, right? That's trained from Spatie. It's going to handle my tokenization, vocabulary, stop words. All that's going to be included in this model. Okay, so I go ahead and I load that up as NLP, and then I go, okay. So I create this. I don't really. This is supposed to be an iterator. I had actually at one point had like this doing multiple, right? Which I can actually do. Hang on. Just uncomment these real quick. Be that, and then all of these would be tabbed, right? And if I run this, which now I'm going to need to run everything. Here we go. There we go. It's coming through now. All right. So when I run this, what's going to happen? This iterator says start at 5823. Right, which is the number that we have here, and then I include some spaces, and this is pretty important, right? Because a lot of the time you're going to have white space, which is going to be really high up there on the word count, right? And double white space, which is really frequent. I'm not sure why. But I say for doc in NLP pipe. What does pipe do? Anybody remember? This pop quiz moment. Pop quiz. What does pipe do?
Tokenizes the stream of text.
Tokenizes a stream of text using a
generator object.
Generator. Yes, absolutely. Provides you a generator. Okay, and we're going to iterate through the generator, which is going to automatically call next, and we're going to keep yielding a new stream of text. Okay, so for doc and NLP pipe, and I call this on my T1, which is my test case 1, right? Just the review text. I don't need the overall right now. I don't need the target. I just want that review body text. I say print doc of I. This is just some housekeeping stuff, so I can kind of keep track of what's happening here. And then I iterate. I raise my iterator by 1. Why do I do that? Because I have another I lock here, and I want to go to the next one. All right. So I increase my I by 1, which essentially just makes it 5824. And then for token in NLP, right? So this object that's coming back, and this actually needs to be doc now. Okay. If not token is punked, what does this do? Somebody who's not John. Yeah, checking for punctuation. Is this token a punctuation mark? Right? How does it know if it's punctuation? Where did that come from?
Isn't that a Spatie function?
Yeah, it came from the model that's pre-trained, knows what punctuation looks like, right? And we're also going to get, is it a stop word that's default in Spatie? Is it a digit? Is it a number? And then string token, right? So this token is a token object. I want to convert it to a string first to see if it's in spaces, right? So I can also check to see, does it exist inside this user-defined list that I've created, right? Is it a space? Right? If it's not any of these things, if all of these are false, then, or rather, if all of these are true, I should say, then we print the token, but we print the token Lima. And this also comes from that Spatie, right? It's coming from that model. So we get the lemmatization and we put it in lowercase. So we're taking care of a lot of birds with one stone here. Okay, but the idea is that we're going to get the Lima, it's going to be in lowercase, and it's not going to be punctuation, a stop word, or a number. That's the idea, right? And Spatie's going to do all of this magic for us. So let's check it out. Name I is not defined. Where did that? Here it is. Let's be an uppercase I. There we go. So Doc 5823, is it a 5? No, it's not, right? And then we see we have all of these words, but look at these words. They're very base words, right? No, they've been lema'd. They have been changed pretty much from the beginning. You see, if you look here, you can see like the first couple of words here, well, comma, now I remember why I don't like this. And this is like classic style stapler. And then all we get back from that is remember, like, classic stapler, look, feel like. Right? So we're breaking out all of these words that are just sort of ambiguous. They exist everywhere. This is the very typical bag of words approach, right? We're not trying to draw out contextual meaning from using all of these filler words, right? We just want to take the base words and embed those, right? And try to drag some sort of topic out of it. Or in this case, we're going to try to use that to determine, is it a 5-star review or is it not a 5-star review? Just using the base words. Okay, and then we get the same thing here. The next one, also not a 5. He's talking about something about the stapler, and it did a horrible job on his Christmas lights. Jammed a bunch and didn't work well, right? So definitely not a 5-star. I think it's actually a 2-star review. The stapler sucked. But anyways, right? These are real reviews, right? So this is pretty cool. So hopefully if our model works, it'll be able to identify that these are not 5-star reviews. But this tokenization, this is basically lowering the dimensionality and the complexity that our model is going to have to try to interpret in order to draw some sort of connection, make some sort of pattern connection, right, between what constitutes a 5-star review and what doesn't. And that's going to be extremely difficult, not least of which because this is not one product, but thousands of different products. Right? So this isn't just stapler reviews. This is everything from like some sort of weird shirt collar thing to power saws, right? So this is going to be really tough right off the bat. And I'm kind of like, if I get a 50%, I'm feeling really good about that, right? But, you know, so this is going to be a tough problem. Normally, I would probably be like, okay, well, let's separate the products out. But just kind of throwing something at it and seeing what sticks, right? So, okay, we've got this tokenized. Does this process make sense to everybody, what I'm doing here?
Yes, but like, okay, I getting confused when you said that we have to use spaCy tokenizer, that NLP is going to be enough with those parameters, because there's like literally a tokenizer, which is spaCy has. And like you can do like tokenizer.pipe, which is, I don't know, it's probably some difference there but like, that's what's confusing. When you like importing tokenizer.
Yeah, I don't do that. I've always just done the NLP pipe because this comes with a tokenizer. Rather,
it's going to be enough when it says that use spaCy to tokenize your data. That's NLP is going to be okay.
If you tokenize, I don't care how you tokenize. Remember that your TLs are the one grading this, right? If it says to tokenize, if you tokenize, that's good. Whatever way works is the right way, right? But what is tokenization? Remind me what tokenization is.
We're breaking down the documents into the separate like pieces, words in this case.
Right. So if you see tokenized data, right, it's usually not going to be so ambiguous, though it might be inferred. Typically, it would be like tokenize this on a word by word basis, right? Mm-hmm. And then however you choose to do that is the right way. You can do it 100% by hand with Python libraries, or you can choose to use a prefabricated package in class, whichever way works, right?
For me, just was hard to understand this differences. Like, okay, you want the same result, but there's different way to get there, you know? And for me, it was not very clear that you can use only NLP. Like, I was thinking that you somehow have to, like, I don't know, make it together, like use NLP and a tokenizer, which is, I wasted a lot of time, which I didn't know what I was doing.
No, that's really okay. And I picked this up because I did the, a lot of the courses on spaCy's website, like the tutorial courses, and getting good at that and reading a lot of like blog posts. Like this information didn't just pop into my head one day. I worked and did a lot of reading to get to this point. But yeah, no, when I used to tokenize, I used to do it the same way with the tokenizer, and then use the NLP.vocab to give yourself words, right? And then use the tokenizer to tokenize. And then I found out that actually NLP just comes with .pipe. And how did I find that out? It was actually, I was just messing around, and I was like, what is in this NLP thing, right? And I was just kind of scrolling through here, and I'm like, pipe? Well, that looks familiar. Right? Like that's the thing I use in my tokenize, and then I tried it out and it worked. Right?
Thank
Turns
you for
out it
making
just
it clear.
yeah, no problem. But like I said, if you know that how to do it and the way that you do it works, there's nothing wrong with doing it that way, right? Someone might build a nitpick like, oh, that's not, you're like your operational complexity is like one factor too high and it could be lower. Those people are weird. Don't worry about that, right? Whatever way works, that's the good way to do it. Okay, so this is the problematic line of code that never actually completes. It just runs for hours. I'm going to walk through what it's supposed to do, okay? I create this list. It's an empty list, and it's going to contain my cleaned version. I'm now going to apply this to my entire corpus, or the entire series that is the review text, right? So now I want to apply, I'm going to clean these up, and I want to put them back in a list, and then I want to feed that list back into the series, right? So all in all, at the end of when this is complete, I should have another column in my data frame that is the cleaned token strings. And that's important. I've learned through iteration since last night that it does not work well as a comma separated list of tokens, but rather join them back together as that initial string. And that there's a reason why I say to do it that way. But it seems to be a little bit easier, okay? In any case, I have a lot of data here, and this runs really slow. So what this does, first it initiates a empty list here, and then for the doc, and I run that NLP pipe on the DF review text, right? It's no longer on my test case. I'm doing it on the whole corpus now, okay? And then I make an empty list for my tokens. So all my tokens are going into this T list, right? And I say for token in doc, filter out the tokens the same way that I did up here, right? So how do I do that? For token in doc, if it isn't punctuation, if it isn't a stop word, if it isn't a digit, and it isn't in spaces. And I just do the exact same thing. This would be spaces now, right? So I do the exact same thing. And then I append the token, the limit lowered tokens, to the T list. And then this is where the magic happens. I join them back together and put them in the docs list. Is everyone tracking this? I found that this to be a pretty simple way of dealing with this whole situation. So we start with this sort of unclean text. Well, actually, I think I've got it down here. Yeah. So we start with this. I hate it when my t-shirt collars, not otherwise. I have no idea where that sentence is going. Not otherwise. To hate shirt collar place button end weird. Really have no idea where that review is going. But you see how we've cleaned this up. We've taken the I, it, all of these nonsense words out, right? We just have words that should have value in them. Same thing. These little magnets are really powerful. Little magnet, powerful size, secret compartment. That sounds like the intro to a mystery novel, but okay. Right? Does everyone see what we've done here? Any questions about what we've done or why we've done it?
Real quick, if you had extra stop words that you needed to customize, where would you put those? In that for loop down there? Okay.
Right here. You see how I did string token not in spaces? Spaces would be stop words. And up here, I would just make this stop words.
Got it.
And then add more stuff.
Is there a reason you do it like that instead of doing a union with the NLP stop words?
It doesn't really matter how you could do that, and then is stop is going to stop it too. I wanted to make it explicit. But yeah, you absolutely can. If you're already familiar with how to do the union right, nlp.defaults. Vocab. dot stop words dot union or something like that. Or I think it's just dot union. No, it is dot stop underscore words dot union. Yeah, you can totally do it that way. And then just make that be stop words. And then you would take this out and just say is not in stop words. Right? That would work too.
Well, then you wouldn't need to, if you union. Okay, yeah, I see. Never mind. I see what you're saying.
Okay, makes sense.
Is the clean column comma separated, or did you remove
Nope.
the commas?
I removed the commas by space
Is that what the
joining
join
them.
is doing?
Yeah, that's what this is doing right here.
Is there a reason why you did that? Like, isn't it a good thing to have it comma separated? So you can actually use
Remember
it?
yesterday when I had just clean tokens and I had to do that hacky sort of solution where I set
Yeah.
lowercase to false, and that makes no sense.
Yeah, and the model.
No
thingy.
idea how that fixed it. That Cooper found. Thank you very much, Cooper. This avoids that whole problem. So now it treats this the exact same way that it treated this.
Oh, so if you
At the
use
end of
like count vectorizer or one of the things, or the TF-IDF, I think that's what we were trying to use yesterday. It won't run into that problem because it's not a list of tokens.
Yeah, because it's not a
props.
it's not a weird comma separated list now. It's just a string. This is just a string, not even a list. It's just a string.
Yeah,
And that's what it expects. That's one of the things that it expects.
That makes sense.
So yeah, so I said DFS cleaned to the first 1,000 docs. So I only had, I think it was like 2,000 exactly. I cut it down to 1,000 just to be on the safe side in case any of them were incomplete. Because it didn't finish running. It ran for 15 minutes and I only got 2,000. I had 137,000 rows. So I was like, this is going to take hours. So we got the first 1,000. I figured, okay, this is pretty good, right? Hopefully most of these are pretty much kind of similar. At least, you know, the 5-star review should be pretty similar in construction, and the less than 5-star reviews should have pretty common words in them, right? We should be okay. Remember, I'm looking at this like 50% is doing pretty good, right? If I can at least get over half, and specifically, I'm looking for the recall to be a little bit higher, right? I want to have a pretty decent recall. So I can't run any cells beyond this because I would have to run this again for 15 minutes, and I don't feel like taking up all that time. So hopefully I left enough of my outputs. Yeah, I did. So we can kind of see what happened. So here's the result of this function is the cleaned column. We've already talked about these are strings, right? Not lists, strings. And I'm hoping to replace the raw text with the cleaned text. Right? This is tokenized, cleaned text. And so I'm going to do my feature target split, right? My X feature matrix, or just series in this case, is going to be cleaned, and the Y target is going to be is5. So I'm trying to predict this column here. And who wants to tell me what this column represents again? This is a check to see if you're paying attention.
If the review was a 5-star review or not.
Boom, you got it. Is it a 5-star review? Remember, trying to simplify this problem because, you know, more complexity requires more iteration. Okay? So I've got a simple problem here, binary classification. I can just use my random forest classifier right out of the box. Shouldn't need to do a whole lot of customization to get a half decent model, I'm hoping. So yeah, here I'm going to import my train test split because, again, good science, right? Don't train on the same data you're testing on. That's just how bad things happen. That's just how bad things happen. Don't do that. Don't do it. All right, cool. I'm going to drill that in a couple of times, subliminal messaging. So yeah, I import my train test split, do my split here, and I've decided, kind of arbitrarily decided how big it should be. This is totally up to you, right? At the end of the day, as long as you're doing a split, you're probably doing it right. Leave yourself enough to kind of get a decent feel for it, though. Remember, I'm really close to 70-30 split, so I probably don't want to make this too small. In fact, I might have done like 0.33 or something like that. Give it a third of the data. Probably would have worked out a little bit better. Who knows? Okay, so I've got 750 in my training data, and I've got 250 in my test data. Not great, but we'll work with it. Okay, here's the part where it splits and there's like 100 different ways to do stuff, right? We need to convert the strings into numbers, okay? There is a whole slew of ways. I think one of your assignments was to find 3 or 4 different ways to do this, right? Whatever way you choose is the right way unless you're specifically instructed to do it one type of way. Okay, but I'm gonna stick to my guns on the right way is the way that works. Okay, so here in this case, I wanted to keep it simple because I wasn't sure how much time I would have, though it looks like I'm gonna have a lot of time. I want to keep it simple, and Spatie has a built-in way of vectorizing words, right? Which is just providing you a vector for the document. So I define a short function. What does this function do? Who wants to walk me through this function?
Are you using only like a vector from Spatie? It's not like a TF-IDF vectorizer?
I did not use the TF-IDF vectorizer, though I could. I absolutely could do that.
Didn't check what this one like look like when you.
Well, you can actually see everything on my screen right now, like the whole process if you look. Because here's the score on my test data. But yeah, who wants to walk me through what this? What is this function doing? How is it doing it? It's converting letters to numbers. How?
For loop does it.
Technically, under the hood, yeah, kind of, sort of. It's like a C loop. How?
Is it just arbitrary?
No, it's not arbitrary.
You're using the Spatie vectorizer. That's whatever model you have loaded into NLP gets.
Yeah, absolutely. So the model is already trained on how to embed words, right? So I'm using the NLP vectorizer, right, or word embedder, and it's giving me back embedded lists. So I get this list of numbers for every string, right? Really awesome stuff. Remember Basilica, kind of like that, though I'm not sure if it's as good as Basilica is. Okay, so I have this NLP doc vector. So what is it doing? I'm using list comprehension here to get back a list of numbers, and I'm saying give me a vector for each doc in my docs. Remember, the doc is going to be this whole string, right? And I want a list of those numbers. Make sense?
One row at a time, right?
What's that?
One row at a time.
Yeah, one row at a time. Absolutely one row at a time. All right, because what are we going to do? I'm going to set up my classifier, right? I'm using very basic random forest classifier, set 100 N estimators because that's going to be the default. A random state. And then I'm maxed up to 7. I don't know if that's good or not, right? We'll see. And then I fit that on embed xtrain. Okay, so that's the cool part. This is where I'm actually getting my vectors, right? So I'm replacing xtrain with the output of this function, which is a list of numbers. Right, it's a list of these vectors, and it's a vector for each document. Make sense? And if we look at the vector is probably a bunch of numbers representing the output of the model and the string. Okay, so I fit the classifier on the training data, and I predict the testing data, and then I scored it. I could have used accuracy score or classification report, right? Which is what I should have done if I was looking for recall. I don't know why I didn't do it. But yeah, I get back, okay, I accurately predicted, and here I took a look at the number of times I predicted a positive class, right, is a 5-star review. It predicted 82% of the total test cases were 5-star reviews. That's actually not that great, because if it predicted, 100%, then 1 star or is 5-star, then I should have gotten around 60% accuracy, 64% accuracy. Why? That's the majority class baseline, right? But I ended up beating my majority class baseline by 4%, which may not seem like a lot, but that's actually pretty good. Number one, it didn't predict 100% is 5-star reviews, right? Which tells me that it did at least get pretty good, or it did a couple of the is not a 5-star review well, right? Did accurately predict the negative class. Does that make sense?
So I'm curious, do you know what the test accuracy was? I mean, train accuracy?
I'm sure it was horribly overfit. Like close to 99.9999%.
Right.
I'm almost positive because this is a random forest classifier with like no good parameter setups. So yeah, definitely some tuning that could be done to make sure that my model's doing a little bit better than this. But my recall is not 0, and that's fantastic to me, right? This was a really hard data set to train a single model on, especially considering my pre-processing only had to do with the text, not the topics. So here's where that topic analysis would come in, right? I might want to split the corpus here based on topics and then run a model on each one, right? Might make a little bit more sense to do it that way. How does everybody feel about this? This is the bulk of what your sprint challenge will be.
Man, I didn't know this for for project 2.
Really?
My project 2 would have been so much easier.
Yeah, probably.
I basically
did you do NLP on your?
No.
Oh, okay.
I broke my basically what I had to do was use the shoe names, break them out, and use them because a lot of times shoe names are descriptive. And if I would have known how to tokenize, I basically just, I don't know if you remember, I took all the most common, I basically did bag of words.
Oh yeah, and you had that huge list of shoe names.
Mm-hmm.
Yeah. I remember. Can I get a copy of your data set saved in my Google?
You should use it for this because it would work well.
I didn't even think about that. Okay. Yeah, pretty cool. So let's touch a little bit on the higher level. What is NLP, right? That was one of the first questions. I think somebody had asked. I apologize. I'm bad with names.
It's okay. Yeah, that was me.
Okay, cool. So like, what is NLP? NLP is processing text. It's making sense of any given language, right? Because do computers speak any language? No, they speak in numbers. Specifically, they speak in 2. At least most computers. Quantum computers, I don't know.
Math is a universal language.
Right. Math is a universal language. Computers speak in 0s and 1s. So we have to translate the human languages, into machine speak, right? Into this 0 and 1 realm that computers can understand. And that's inherently very difficult. Our brains are very complex computers that our machines, as wonderful as they are nowhere near the operational capacity of a human brain. Okay.
I want you to prove it. I want you to run all of the descriptive words through a translator.
No.
See if you get the same score.
This machine is very good at a specific set of tasks, right? But it can't think. It can't cognate. It can't draw connections between 2 abstract thoughts. Okay.
No.
That's the thing that is human language, and we're trying to, translate that to a computer. How do you define what's mean and what's nice? That is a very abstract concept that the human brain is very good at recognizing because of its, innate neural connect, or rather the type of neural connections that we make. But machines don't have that. They don't have that capability. So we have to try to find new and creative ways to make those connections, and get a computer to recognize these sort of things, right? Like I can very easily look at a review and say, okay, he's complaining that the stapler is misfiring and jamming. That's definitely not a 5-star review, right? Computer has no idea, no clue, right? I give it to a computer and it says, sweet, here's a string. Looks like a string, right? So we're trying to find ways of converting these words into numbers and then using really fun looking math that has very few numbers and a whole lot of Greek characters to try to explain to the computer how to process the numbers that we give it. All right. So we give them this really cool formula and we tell it, okay, convert these words, this string, into numbers using this formula. All right. And then it does so. And then that's supposed to make it a little bit easier for the computer to try to make some connection, or rather establish some sort of pattern between this is 5 and not 5. And that's what the fitting is doing. All right, so when we fit our model, we're like, okay, here's a bunch, and we're going to show you what the result is, right? And all it has is these big lists of numbers, and it's trying to figure out what the pattern is. And it did a pretty good job. all things considered. I didn't give this model a whole lot of help, right? And it did a pretty good job all on its own, just a bunch of numbers. But does that kind of clear things up a little bit for you?
Yes, and I wanted to ask, will we need to do a sentiment analysis tomorrow for Sprint Challenge or no? Because
I don't think
haven't-
so. No, you shouldn't have to do sentiment analysis now. In fact, I don't even think you have to do topic analysis. I'm pretty sure you don't have to do topic analysis. Though if you do, you would literally just copy and paste the code from your from your today's assignment, right? Gensum pretty much does all the work for you. It would be a very simple topic analysis. I don't expect that I would be able to do that very easily off the top of my head. So, yeah. I don't know if they've implemented that into the Sprint Challenge yet or not. I won't get to see it until tomorrow morning, unfortunately. But yeah. So, question time. Hit me with questions.
It's pretty straightforward.
I thought so, but there's a lot of things still kind of abstracted away in there. I didn't really.
Oh my gosh, like this is super interesting. There's so much I want to do with it, and there's not enough time in the day.
Yeah, that's a huge problem. And it gets worse, man. It gets worse as you'll see what I mean. Like you'll be like, man, I need like 3 or 4 weeks to study all this stuff, right? You just say, no, you get like a day.
My books to read
Yeah.
are just piling.
Yeah, so are mine. Believe it. I've got bookmarks on bookmarks.
Kind of like a tangent on that point. I was talking to a few people after the office hours. It kind of came up as a joke during office hours today to have like a DS12 book club, and I was thinking about starting that. Whether it's reading actual books or just reading resources about what we're learning and then just talking about it with a small group of people.
That'd be amazing. Or even like blogs.
Yeah.
The only challenge you're going to run into, because we did something similar in DS8, and I don't mean to dissuade you, absolutely do it, right? You can start up your own channel and start inviting people right away. You might run into a slight problem, though, is because after this week, it gets even harder. You're going to spend so much time with this material, you're going to be like, oh boy, I don't have time, right? But going into labs would be super cool to have something like that going on, right? So like in your downtime, when you're waiting on like front end to do something, you can be
perfect.
Checking
stuff
out.
In 4 weeks, we'll start it.
Yeah.
No, I'm telling you, I'm not trying to dissuade you. Do it right now. It's a super cool idea. I absolutely love the motivation, right? But just letting you know, it does get a little even more fast paced, even more random knowledge drop, right?
But if it doesn't catch on, I would totally be down to retry after.
Yeah, totally.
I figure might as well give it a shot, and then it makes it easier to start it up again.
Yeah,
so
totally.
I have to do some more work tonight, but if I don't start the channel tonight, I'll start tomorrow and I'll drop it in DS12. Yeah. So
Right on. Right on.
Sounds good.
How do you have time to have so many books to read? Like I don't have time to even study what we have to study.
See, that's the thing. I feel like I could better use my free time and have that kind of like support and like accountability of a group to read the same resources. I think will help me
It would help
personally
me.
a lot.
I'm ambitious, but I don't know if I'll be able to read any.
You gotta have someone
Show
keeping
up
you
and-
honest, man. That's
A
what
group
groups for.
that I know that was formed was they distributed the labor. So instead of everyone reading the same thing, each person takes a different thing that they're interested in reading and then reports back the findings and what's interesting to everybody else.
That'd be fun.
Yeah,
Yeah.
no, that's a really great idea, actually.
Mm.
But yeah, however you choose to set it up, I think that's a wonderful idea. I absolutely 100% endorse that and would definitely be a part of it. I think it's great. Like I said, I've got a ton of books piled up that I just haven't read yet either because, either A, that game looked really, was really distracting, or, I was researching something else. I've been known to get sidetracked on physics tangents too. So like I have to try to keep myself focused sometimes. It's really hard to do. Yeah, I think it's a wonderful idea.
The YouTube rabbit hole has been insane since I've started this because it's opened like a whole new realm.
Yeah, I haven't seen a whole lot of new videos coming from my only subscribed channel, which is PBS Space Time, as most of you could probably have guessed. So luckily I haven't been on YouTube much lately, but as soon as they start releasing videos again, you won't see me anymore. I'll be gone. because he always throws out like huge math problem or
Subscribing
crazy
now.
problems, and I'm like, I gotta go. I gotta solve these problems. Like one time he tried to like get us to estimate the actual miles of the width of the universe or something like that. It was crazy, and it took me like 3 days. So yeah, love the channel, but he's always giving out brain teasers. Anyways, back on track. NLP, right? The primary goal of the sprint challenge, and really in NLP in general, is to make sense of text, right? So whenever you're faced with an NLP problem, it's usually because you have large bodies of text and no context, right? Like you have no idea what to do with it, or you need to use a machine learning model to try to do something. But again, you have large bodies of text. How do you process that for a computer? Enter NLP, right? At the high level, that's what it is. Right? So you were doing NLP when you were changing, or rather, remember when you did like ordinal encoding with the sklearn libraries? Technically, that's like baby block level NLP, right? You're just straight up arbitrarily converting words to numbers, right? Technically, that's NLP. Just think big baby blocks, right? You're in elementary mode, then that's fine, right? For a lot of problems, that's really all you need. If you just have one word, you just need to convert it to a number and you're done. The higher level problems that we're solving is like trying to find context in these docs, right? And then trying to make a string of numbers or these vectors that represent the idea, not just the word. And that's far more challenging. We're going to get into some even crazier methods next week, which is going to be really fun. Talking about LSTMs and stuff like that, which is like long short-term memory, which that's going to be really fun to try to wrap your brain around. I'm still trying to wrap my brain around it. Yeah. Any more questions about the stuff we've covered this week?
So you went over that really fast. Can it really be that simple?
It can. It can. A lot of the time, if you're encountering issues, tokenizing, processing, anything like that, like, guys, I wrote this whole notebook in like an hour. It can be done, right? Most of the time, it's because you get stuck overthinking. So I advise you don't overthink. Adrian, don't overthink.
Sorry.
This dude's perpetually overthinking. No, I'm just kidding. I don't spotlight.
Maybe if he doesn't write like the nth dimension for loop.
His like 3-4 level nested for loops drive me nuts. But I digress. Yeah, if you don't overthink it, it's actually pretty simple, right? At the end of the day, you need to clean the text up. You need to get rid of stuff you don't need. Ask yourself, I'm doing coffee shop reviews. Does the word coffee mean anything? No? Toss it, right? I'm not sure. Toss it anyway. Probably okay. Right? What I did was very high level, very kind of just skimming the surface, but I ended up getting a result that was better than my expectations. And I still beat my majority baseline. I have no idea how I did that, right? Shouldn't have actually done that.
What if there was a correlation to how many times coffee was said in a review to the rating?
There could be, but that's for like research side of things.
Oh, okay.
We're in production. We're talking about, your employer, whoever that may be, is like, I've got these texts, I've got all this text data, make some sense out of it. You got a week, right? You're not doing research on all this text in a week. That's a months-long, years-long process, right? You're going to take established SOP, which for the non-military speak out there, it's, standard operating procedure. And you're going to apply that to any given problem that you have, right?
Oh, SOPs are very real in the real world. We use them every day.
That's what I'm saying. You're going to have an SOP. Anywhere you go, I promise you, unless you're going to like a brand new startup, never heard of data science.
No, then you're writing them.
Right? Yeah, unless you're going to a brand new startup, you're going to have, whatever you're going, it's probably got an established data science department. They probably got an SOP for dealing with these things, right? So you're just going to follow that SOP. And at the end of the day, all you're expected to be able to do is high level analysis, right? If you can do that, you're most likely, shoot, you can fake it till you make it, right? But you'll be able to hold your own in an environment where you're asked to either perform some analysis of a function that was already made, or to write a low level or high level function that can do something similar. Right? So that's kind of why I'm like, you don't need to, or rather don't stress knowing all of these methods and all the attributes of every class, right? No one remembers that stuff. They just know what it is. They got like a record of like stuff that's kind of important, and then they go, oh, I need this. Then they go look up the documentation for it, right? That's your skill. That's your toolbox that you should be carrying around everywhere you go. It's like knowing what tools you need and knowing where to find the documentation to use them, right? That's it. That's the key. Like straight up, if someone asked me to do an LDA right now, I would fail without Google. It absolutely would not happen. Right? I'm going to need Google. I'm going to need somebody who's wrote a blog on this. Right? So
that's what makes me so nervous about interviews. Like, hopefully they're open Google, because
kind of, sort of, you're going to have whiteboard problems. You're going to have pseudocode problems. They're going to be like, okay, given XYZ, how would you go about solving it? Right? And that's a very open-ended type of question, but you'll get more into that post labs. Okay, they're gonna teach you how to deal with those types of problems. Absolutely. Now's not the time to worry about that. Cool. Any other NLP related questions?
Are you going to send us that notebook?
Yeah, I can if you want to.
Do you have the data too?
I sure do.
If you wouldn't mind sending that too.
It's kind of big. It's a couple hundred megs, I think.
That's all right. I'm actually going to try to translate it and see if I can't do it in Spanish. I want to see what happens.
Oh, that's pretty cool. Yeah, Spacey's got a model for Spanish, so you should be good to go.
I don't think it would really matter, but I just want to see if the scores are similar.
Oh yeah, okay. Right on. Yeah. Give me a little bit for that. I'll see if I can get it to you. I can probably Slack it. Here, let me see. I've got time. Hang on.
It should matter if you're gonna take the Limas, especially.
Yeah, I figure keywords though. I don't know. We'll see. I mean, I would expect it not to matter too much, but yeah, I mean the Limas are definitely because you specify, right? Do you specify the language? Or that was a vectorizing, right?
The vocab of Spacey.
Yeah.
Of NLP.
So when you're using NLP, because I loaded NLP as the English model or the EN Web Core Web Large, you need the Spanish model in order to do that.
But I can
run it on the same data.
Yeah, I can just run the translations through after it's already
Well, if you're
the bag of
running a
word.
translation algorithm, you're already like really manipulating the text in a weird way anyway.
Yeah.
Yeah, true. And translators can be iffy because some languages a lot gets lost.
Yeah, I figure it's not going to be perfect.
But I don't know, Spanish is pretty close.
Pretty good for Spanish.
Yeah, pretty good for Spanish. But something
I
like,
mean,
I think
Spacey's trained on native Spanish is what I'm saying. So you're going to get weird results.
Oh,
that's true. Yeah, a lot of different types of Spanish.
Does it translate it for you if you like feed it like an English sentence, or is there like a translation thing in Spacey?
There probably is a Python library for it, but I doubt any of those do it.
Okay.
After hours. Notebook. So there's the notebook and getting the data now. Oh my goodness, my C drive is almost completely full. That's not good.
I'd imagine a lot of the actual language is similar, but the syntax relevant in the way that we do like embedding?
Probably not. Tokens, right?
Well, I mean, like document specific, the syntax within the document, and like, I guess it's really more relevant topic analysis, maybe.
Yeah. So the data's, yeah, oh, I'm sorry, I didn't mean to cut you off. Go ahead.
No, it's this question for people who know more than I do.
What was the question?
If you're using like an automated translator, I'd imagine a lot of the vocabulary might be the same, but the syntax is really different. That's what you use in a lot of auto translators, but it may or may not be even relevant with what we're doing.
That's kind of my theory. I don't think it really will be, just because I mean eventually it's all going into numbers anyway. It's just looking for relevance to the words. And
that's not that's not something I have an answer for right off the top of my head, but I would say
I'm just really interested to see if it's going to get close to the same results regardless of
Find out
the language.
Yeah, totally.
Because we were talking about this. Were you in the office hours? We were talking about sarcasm and stuff like that.
Oh yeah. No, I've got a research paper written by a PhD candidate I got to read about semantic, or rather sentiment analysis. Which is really cool. It's actually using instead of an LSTM, which is kind of what we're going to sort of kind of do. It uses convolutional neural networks, so I'm interested to see how that works. But yeah, sentiment analysis and like detecting sarcasm. Kind of think in this case it was like rude, inappropriate, terroristic, and threatening was the different classifications it was trying to determine. So it's really cool. It's a tough subject though. This is a nut we're still trying to crack. I think the most reliable sentiment analysis is actually polarity analysis, and it's not great, but TextBlob basically can tell you about polarity, and I believe that's actually in one of your assignment notebooks talking about TextBlob. Check from module 3 or 4. Yeah, pretty sure he brings that up, but it's pretty cool, and we used that on the Hacker News, and it was fairly accurate, right? Like the ones that classified as being negative were typically pretty negative, and otherwise, and vice versa. So I think overall it turned out to be about like 70% of the cases I reviewed. There's no clear-cut scoring for that, but pretty good.
That makes sense. Trying to simplify like you're using qualitative information and trying to process it quantitatively. A Boolean does make sense.
Yeah.
I'd imagine that the syntax matters most in sentiment analysis because it really
very much so
heavily on context.
Yes, very much so. Context is everything, and it really sucks when people can't type. You basically have to toss them. Like I can't do anything with this. You don't know how to make words. Right.
That's like a technique now.
What's that?
Like it's like a pro privacy technique.
It really does make NLP super hard when people write badly. That being said, there is a new and upcoming, like I have read about the implementation of this sort of, one of the uses they're going to try to use quantum computers for is this cipher, or like code ciphers. And code cipher would work for like leet speak and stuff like that. People try to type really bad on purpose, right? To encode how they're talking, but this thing would be able to crack that in like minutes and then create a full dictionary on it. It's pretty cool. But yeah, it's not implemented yet.
Yeah, Google Translate has a Python.
It's got a Python package API?
Package, yeah, and it's got a lot of languages actually.
Yeah, I imagine they're like leading the field right now. In fact, their translation software is actually really, really, really good.
What was the name? Sorry?
It's Google Translate.
Oh, Google Translate.
And
actually, it's import Google Trans, and then that's it.
Oh, cool. Yeah, right on. What were we saying, Chelsea?
Spanish is really close to English, so it's probably comparable compared to some of the more obscure languages.
I think it's like it's just in the SOV. I think we're SOV and they are like SVO for some things. Is that right? Subject verb object or subject object verb. And I think we're the opposite. The O and the V are swapped between English and Spanish. But once you figure that out, it's pretty simple, if I recall.
Also wanted to say that I created the channel and dropped a link in DS12 for DS12 Book Club.
Sweet. Yeah, absolutely. I'll go ahead and join right now.
There's just more content to train on Spanish and English compared to a lot of other languages.
There is, absolutely. Spanish is like one of those languages, like, I need to go learn Spanish because it's becoming very, very, very widespread, and not knowing it is more of a hindrance than and it used to be like a novelty. Now it's not so much. It's like you need to know.
Learning one language makes every language seem less foreign too.
That's true. Yeah, I
understood
started learning
kitchen Spanish real well.
my grandparents still get in fights though because they speak 2 different types of Spanish. It's really cute. We've been together like 40 years and they fight every time. Like, you don't know how to talk. What's wrong with you?
What kind?
Oh my gosh, don't give me a line. I'll have to ask my sister. She's more familiar with that, but I just remember.
There's some heavy accents.
Yeah.
Really lucky I learned from very slow, clear speakers.
Well, my granddad speaks more of a very relaxed, informal type, and my grandmother speaks like a super strict, super formal type of Spanish, and they just always knocking heads over that. It's really cute.
Is Mulas, is your last name Spanish?
Spanish,
Okay.
yeah.
Mulas.
Yep.
Mulas means mules.
It's because we work hard. Believe that.
It's badass.
It really is. You see
Can't
our family crest
reproduce.
is pretty cool. Huh?
Or you can't reproduce.
Oh no, that's not been a problem. You should see our family. It's huge. Well, kind of digress. Does anyone else have any major questions? Anything that they're unsure about prior to the sprint challenge?
Super appreciative if you could share the notebook.
Already done. It's in the DS12 After Hours channel,
Thank you.
along with the data to make it work.
Everything is perfect until that sprint loads on the computer.
Yeah, and then you're like, how do I words? What? I know how it is.
Much.
Yep,
I'm
I
so
know how
happy
it
we're
is.
back to notebooks. I'm not gonna lie.
I figured a lot of you guys would be, and so I was like, yeah, make it through Unit 3, and then it gets
And like every brown bag that I've been in, they've been like they'll show us a notebook that they're
Right.
working with and stuff like that too. So it's like, oh, parody.
And the truth is, you can do a lot of Unit 3 stuff in a notebook. It's just like when you talk about, application packaging and stuff like that, no, you can't really do that in a notebook. It doesn't make sense in a notebook. But now we're back to more data science, strictly related stuff, right? Like that was more DevOps than anything else, but it's something that you'll be in contact with and see a lot of. So it's definitely something you need to be familiar with, right?
I assume there's a lot of thought put into it, but is there any specific reason why Unit 3 and 4 aren't switched? Because it seems like more of a natural progression of predictive modeling to go next to NLP and neural networks.
I couldn't honestly tell you what the reasoning is, but there is,
Hype you up. So
yeah, there may or may not come a time in the near or far future. I have to be so vague about this because nothing's been said publicly yet. There may be a time in the near or far future where the order of some of these gets switched around. Right?
you're not the only one that hears these rumors. I heard labs are getting pushed, and we're going straight into CS.
Yeah, I heard we're going straight into CS as well. I thought that was already
It very well could be. Yeah.
No, it hasn't been confirmed. I don't believe.
Oh.
Wait, I heard it was totally confirmed, but probably from non-great sources.
I haven't heard it yet, so take it with a grain of salt.
Like I heard that DS12 isn't in labs.
What's that?
Oh wait, no, DS11. Sorry, I heard that DS11 isn't in labs. They're in CS.
Well, I can confirm that because DS8 just got done with CS, or is actually still in CS, and that's my cohort.
So is DS11 in CS right now?
No idea. I can confirm it for you though. I'll hop in the staff channel and find out about it.
Remind me what CS is?
Computer science.
Oh, sorry.
It's where you go back to Unit 3, basically. Like you go back to Unit 3 and you go back hard to Unit 3.
We just escaped.
Yeah.
Well,
Go back,
they're on auto encoders, whatever that is.
Autoencoders, you'll learn about those in week 4.
They're on, yeah.
Yeah, deep learning neural network stuff. Autoencoders basically is dimensionality reduction for neural networks.
Shouldn't they be done with that?
It's more in depth. There's a whole, I think, like a couple of days on recursion. It's more like computer programming 101.
So they
than
are
anything.
in CS.
Yeah, well, I don't know about DS11. I'm just telling you what CS is. Yeah, it's like a programming 101 college class. Imagine that for a second. That's kind of what CS is.
Is it like basic Python?
It's Python.
The first week is literally OOP in Python.
Yeah.
But
Say,
we're
you're
lucky
literally
because-
going back to Unit 3.
like they're all coming from JavaScript to Python. Like everyone's coming.
Yeah.
from JavaScript,
Like all the web cats
which
are
is
coming.
90% of Lambda. So like I don't know how, but it's great for us.
Wait, they all do the same CS that we do?
Yeah, we all go into the
Yeah.
same CSs.
Oh,
Yeah.
okay.
You're gonna
And
be in the same.
honestly,
You're gonna
like-
be paired up in labs with web folks too.
When I would speak to web folks at like the meetups when they were a thing, like they didn't even know what object-oriented, like they barely knew what object-oriented programming was.
Yeah, and that's all of like JavaScript's mostly object oriented nowadays. Like React, I think if I recall correctly, is like almost entirely object oriented.
So maybe they just didn't know the name of the concept that they were
Right.
using.
They probably didn't. No, I've been worked through a little bit of the JavaScript curriculum. It's not great.
Yeah, I heard it's a cluster over there. There's just so much information all at once.
Yeah,
JavaScript
they
sucks.
have like a week to do JavaScript. A week, my dude. Come on. I learned ultra fast, and it took me like 3 weeks to even understand kind of sort of what JavaScript was doing.
But I
Right.
thought that we learned more shit.
Dirty. Sorry.
A little bit. As far as like programming language goes, yeah, most of the stuff that they learn is more web specific, right? Where our stuff is more lateral. Like more the scope is wider
yeah,
on
the
stuff
scope
we
is
can do.
definitely wider for us.
Yeah, yeah.
Hmm.
So that's why going into CS we kind of have a leg up. It's really nice. There'll be some new topics, but most of it's just going to be going deeper on things we've already covered. So not very complicated at all. But again, we digress. We have tangented. NLP. Any more questions?
I think after realizing that everything that you went over is kind of the main chunk of the sprint, I feel way better. I feel like please someone speak up if I'm wrong and they want to ask more questions. But I think that's maybe why we were tangenting.
Yeah.
Okay.
I think that going off of last unit as well, I think they really need to, I don't know if they need to like make it a different color or whatever, but they need to like specify that this is the main focus right here, and then we're expanding today on this because it relates and stuff like that. But if they definitively told us like what the core stuff was, what you really need to know, especially for like months like this when life is just crazy. But if what you showed us is what the sprint is on, I feel okay.
Very, very much largely, at least. And when I came through, that's all we did. Though I think there might be something on topic modeling there. It all kind of falls into place, right? If you think about it, document classification, topic modeling is just defining or classifying the topic, is it not? You're just using albeit a slightly more convoluted way of getting there. What is LDA? Almost describe that to me.
Latent Dirichlet allocation.
Yeah, well, I didn't mean the name. I meant what is it? Yeah, because latent Dirichlet, I think that's the name of the guy who came up with it, as I recall. Googling. What's that?
Dirichlet.
Whatever his name is. Latent dude man's name allocation. Yeah.
My like caveman understanding of it in my head right now is that you like give it how many topics you want to see, and then it tests out that and compares them and sees if they're dissimilar, and then it tries to adjust it a little bit, and if they get more dissimilar, then that's the new one it's going with, and then it like adjusts it again, and like it kind of randomly tries, and then it tries to get the topics as like distinct as possible, and if it doesn't make them more distinct, it kind of goes with the last iteration.
I wouldn't call that caveman. I would say that's like a high level understanding of it. You essentially gave me everything but the equation, which is pretty good.
I definitely don't know the equation. That's for sure.
No, it's it's one of those things. No numbers, just a bunch of letters. But yeah, no, it's really cool. Yeah, it's almost exactly what it's doing. But yeah, the whole idea is to take from or rather iterate through the words available in any given corpus and try to determine what the main topics in that corpus are. The more different varying topics of text that you have, the harder and longer that process is going to take because of what you just explained, right? That's more iterations, that's more slight adjustments that are having to go on to try to find the right selection of topics, right?
So is that why you have things like passes where it kind of starts at a random seed and then it'll try again with a new random seed to see if it can improve on that last iteration of distinctness? I don't know how it defines distinctness. But...
Yeah, and that's a concept that kind of feeds itself, or rather lends itself really smoothly in a transition to gradient descent, if you remember what that is, right? You're trying to get to a new global minimum. And that sort of random seed switching is that you're trying to tunnel out of any given local minimum, right? You're checking to make sure that if you move drastically in one direction or the other, that you're still going back to center. And if you are, then it's assumed that's global.
But is it doing it like gradient descent, where gradient descent kind of learns from the previous iterations? Like with the next pass, it kind of is like a restart. Whereas in gradient descent, it's not as much of a restart, right?
Kind of. The difference is almost semantical, but it's all in the math at that point. It's difficult to explain because I don't understand it well enough. I do not have the ELI 5 understanding that is required, I think, at this point to explain the differences between the mathematics there. That's the way I think of it in my head.
Cooper can attest to this. In our TL group, we recently got a master's in math added.
What?
So that's it. And he's like, if you guys need help with the math, then
that's awesome.
So I hope you can enlighten me on some of that.
Sweet. I started this when I was still working my way through integral calculus, so
the new TL.
I kind of got a pretty good idea of stuff, but
it's a new guy added to our group named Chris Huskell.
Oh, okay, yeah.
That's
How? I mixed it up because now we have so many Chris's in our group. We have Chris Husky and Chris Howell. I combined the names.
Yeah.
Are you trying to differentiate between was one of them doing like essentially a Bayesian technique and the other one? Okay.
That's what it seems like, yeah.
Is the named entity recognition? I kind of missed that part. Is that like domain knowledge, basically importing some domain knowledge?
Yeah, and Spacey does a really good job with domain or a named entity recognition. So I would definitely look in Spacey for more of that. They do a really good job with it, actually. It's pretty cool. And you can define your own custom pronouns and stuff like that. It's really awesome. Kind of expand that list depending on the context of what you're dealing with, right?
Can you show us, if you have time, this topic modeling, like in a fast pace at least? Like you're not sure that if we're gonna have it tomorrow for spring.
I don't think so. Let me see if I can find out real quick.
No, even if not, like at least again, but like because you have this ability to show it like what's really important. Because during the lecture we're getting like a lot of information, and not all of them. Like it's as I told you before today, it's hard to filter, like what we should use and what we better just skip, and this is really helpful.
Well, yes and no. So I like to have things structured out because when I'm going through, like when I showed you today, it was all like streamlined and everything was already well thought out. My thoughts come out of my head in a jumbled mess. So I would need some time to get that like kind of compacted and put into some readable format. You saw yesterday what that looked like. That's not good, right? That was a mess. So if you want, I can compile something tonight and then have it ready for before hours in the morning if you want to do that for topic modeling. Would that be okay?
Are you having before hours tomorrow? Because I saw in Slack that Nick has a before hours.
I'll just bomb his before hours and then start my topic modeling presentation.
Yeah, the only thing I want to go over is today's notebook, but otherwise I feel pretty good.
Yeah, topic modeling is one of those things that you just kind of got to go deep. And like I said, right now, like you asked me to do it, I'm like, no, I've got to pull resources. I've got to do some searching, right? Kind of get refreshed on everything again because I didn't even sit through the lecture today. So, yeah, totally possible for me to do something on it and then walk through it and make it make sense. I'm just going to need some time to prepare that. So it's just really deep, but not so incredibly deep that it can't be understood. Right.
Mind if I ask how often you sit through our lectures?
Once or twice a week. Odd question, but yeah, that's where I'm at. Usually once.
As doing these after hours made you like so much better.
Yeah, that's actually one of the reasons why I became a TL is because I was doing these all the time with my group every day. So it's like I'm already kind of doing the TL job, but for free. So I should get paid. And that's right. That's how I ended up here. But yeah, no, teaching stuff is a great way to solidify your own understanding of it. So even if you don't fully get it, you just go to start teaching it and you get people asking, well, okay, well, what about this thing? You're like, well, I don't know about that thing. I have to go look that thing up. And then you get better at it, right? And every time you, or rather when I'm compiling my notes, right, it's usually a good time for me to learn and kind of see, like, make mistakes a little bit, like, okay, well, you know, what worked, what didn't work. And then when I come to teach you guys, I've usually hashed those things out already. So it's pretty fun, right? It's a good experience.
Well, even John Cody said that. He's like, when I was doing it in the real world, like I didn't really understand what was going on in the background. Now that he teaches it, he's gone and researched it. So
exactly, right. Every time I look at something or look at one of these topics, I get a little bit deeper in it. So that's good. Learn something new every time.
Thank you so much.
Any of you guys interested in becoming TLs? I've already applied it for TL.
Little
bit.
I think I'm sending my application in tomorrow before they're due.
Right on. Yeah, definitely get that in. Because they message us too. They're probably going to message your TL like, hey, your student applied. What's up? Who's this person?
Yeah. No, I had talked to Tally about it, and he said to message him before I send it in, so he knows.
Yeah, right on. Cool. Well, what's if you don't mind me asking, like, is there a holdup for wanting to be a TL?
My initial holdup was that it was going to extend my Lambda graduation date, and so now I'm applying to be the part-time TL so I can continue being a full-time student. And particularly like you said, what you mentioned, I'm really excited about. I find that helping people learn helps me learn and solidify the knowledge so much, and I enjoy it. So why not get paid for it? Is definitely the way I look at it.
Yeah, no, absolutely. It's been one of the greatest learning experiences that I've had at Lambda so far. So that's been pretty awesome. Yeah, one thing I don't tell people much is like I passed this unit. I think I got a 3 on the sprint challenge. I only actually attended 2 days this week when I came through the material myself. And then I crammed everything the last night. So yeah, that's real cute. But not the best way to learn, right? Like I passed my sprint challenge, but mostly because I just had really good notes. Didn't understand a bit of it. So coming back through it now, it's like, okay, yeah, no, that's making way more sense.
Don't you guys check the homework every day?
Yeah. I look at a lot of homework. Some of you guys are great at coding. Some of you guys are like stream of consciousness.
I don't think I've had anyone check my homework since like week 1.
That's crazy.
Nick reads through it. He just doesn't tell us unless we ask.
I don't typically say anything about it either.
Because he has to send the grades in.
Wait, I don't even do the module retrospectives.
Yeah, I've got a couple that are pretty bad about module retrospective. I'm looking at one of you really hard right now. But anyways,
I don't remember.
I'm not saying.
I send mine in every day.
You do?
I don't. I haven't sent one in since
every day. I think Tatiana and I are the only ones that do it.
For a while, they were
No,
like.
I sometimes miss it.
Oh, do you? Because Nick has said that we're
Like
the
this
only
week I
two
only
that
sent
send them.
2.
Yeah. Well,
I also
for Unit 3 only had like 3 people sending in module.
I also do.
Oh,
all my,
same. Unit 3 I didn't send. I don't send any.
I also do all my career assignments.
Yeah.
It's like the same questions over and over again. It's like taking a survey daily.
Yeah,
the career thing needs to be revamped.
annoying.
It's obnoxious. Yeah.
I totally know about that. Actually, I need to get with my team about the careers thing because I haven't even looked at their submissions yet. I think there's only like one person submitted anything for careers yet. But
Nick said I'm not hireable, so I'm not doing that.
Oh, ouchie.
Did someone really tell you that, Andy?
That's crazy.
Yeah. Nick is he has me at a 5 rating for hireable.
That's what I put most people at because let's be real. You know, if I had to rate myself right now, I wouldn't be higher than a 5.
Buddy, I wouldn't hire me.
That's what I'm saying. I wouldn't hire me right now. Like, I definitely got got a lot of stuff to work on. So
But is that some imposter syndrome a little bit? Because
probably a little bit for me, but I don't really know. Like everyone I talk to is all like, "You're a savant," and then I'm like, I don't see that. Like I see huge gaps in my understanding.
Because I think you'd have 13 recommendations right here. Just
watch your videos.
I give you a 5.
You don't
Yeah,
get to that
Andy.
point with the attitude that I already know it all. So
What's that?
you don't really get to that point that you're going for unless you maintain, like, I still have room for improvement. I always get bugged out if I don't get enough, like, I need criticism.
Yeah, right. Like I live for it because it's kind of like, the status quo is great. And then like, if everyone was just like, yeah, you understand this, I'd be like, where's the fun in that? I would lose interest like dumb fast.
Honestly, these after hours alone should get you Lambda endorsed.
I don't know about all that, but I'm glad it helps. And that's really what matters. And yeah, I think if you guys want to see some like topic analysis stuff, I could definitely get something ready by tomorrow.
Yeah, I don't think I would have passed Unit 3 if it wasn't for you, bro.
But yeah, like so with tokenization,
Honestly.
it should be hopefully cleared up, right? Like what are we doing with tokenization? What is the purpose?
Splitting up words.
Splitting up words or splitting up characters, right? Sometimes you're training a model not on any given set of words, but any given set of characters, right? Think what is the application of character tokenization? Anybody know? What could you do with a model and character tokenization? I want you to think about your smartphone.
Okay, say it again.
Text reading.
Autocorrect. Yeah.
Autocorrect. Or like predicting what the word is you're typing, right?
Autocomplete? Yeah.
Super simple stuff, right? But that technology was years in the making. You had people bending over on that, and it came down to properly tokenizing characters, right? And
it was garbage.
Right?
I mean, it started with T9 though, right?
It kind of did, yeah. That's what I'm saying. But it took years to develop that technology, and now we're talking about doing that. And
I feel like half the people here are too young to know what T9 is.
I know a lot of them are. It's where you had the flip phone, and then you only had the number characters, but you could just like type the numbers that correspond to the letters of the word, and it would like.
Yeah.
It was pretty fast.
It was, yeah. If you were good at T9, you could text like dumb fast.
What?
Back in the day, yeah.
Yeah, see, Adrian.
Adrian's like, I've never heard of
literally
this.
have
I
no
always had
idea-
letters.
I've
I
never
don't know.
heard of it.
So you used to have to press buttons to dial.
The cool thing was,
dude. Hey,
You had to press.
He,
You had to press.
he doesn't even remember the days that you had send messages with numbers on beepers.
Oh my god, yeah, pagers. I had a pager. That was great. They're great times. I'm so old. I remember the freaking turn ones where you had.
What
Yeah,
the?
But I never had one. But I had a buddy who had it.
I thought those
man.
were only in museums. I don't know.
Yeah, it's been crazy, right?
You hated people. You hated
my,
people.
My
with
mom's
like,
got one that you had to crank in order to get it to run. You had to generate the electricity yourself.
Yeah.
Freaking wild.
That wasn't generate. That was to make the spark.
I don't know. You had to crank
Jesus,
it. I assumed it was like a generator.
What are you talking about? That's to make the spark, to make the beep.
Let's make the generator object.
One of those
make your own
weather radios on the
Yeah,
phone.
exactly. You had to crank it. I don't know. It was wild. Anyways, I thought that was pretty cool. But yeah, so tokenization, character level tokenization to implement, on a model that's trying to predict what the word is that you're typing, and then word, tokenization. What could that be used for? Well, imagine trying to stuff like what we're doing, right? Trying to figure out what is being said in any given sentence or a group of sentences, right? By word. And then what if you had like huge research papers, and maybe then you would tokenize by sentence or paragraph, right? And characterize based on that. So there's any number of ways that you can tokenize, but really all it is breaking the text up into manageable bits.
When you say, sorry, I didn't mean to interrupt you.
I was just saying, is parsing like a synonym for that appropriate?
Parsing. Let me check that. Hang on.
I think yes, but I definitely think we should check.
The follow-up on mine was why, like, what would be the benefit of tokenizing a sentence or a paragraph versus a word?
If the docs are just enormous.
enormous stocks. That is exactly.
So it's basically about memory. There's no like
conserving memory.
But maybe also it would just be insane.
There's no predictive benefit, I guess.
Well, you're at that point. It's a trade-off. Like, how much information are you maintaining or keeping?
For example, Google Translate, like to get an idea of what's appropriate syntax, if something what's the most common syntax for a certain word, maybe gives them a certain idea that is the correct syntax and it learns over time.
Yeah. Yeah, and if I recall correctly, it also was able to be corrected, and then it would learn on that.
Yeah.
I have a really crazy question, dude.
What's up?
What about like context when you're tokenizing? Like, for example, and I'm just going to throw this out here because it's just barbaric, but like, let's say you're reviewing rap CDs.
Mm-hmm. Okay.
In the context of the words that people are using to describe them.
Yeah,
we talked. Positive words might be negative, or negative words might be positive.
We talked about this with sarcasm in the office hours, and obviously, there's no way for the computer to know. I think someone brought up, neural networking and chat bots.
Absolutely, 100% neural networks is the only way you're going to be able to develop a model that's complex enough to be able to determine those semantical differences in text. To be able to detect something like sarcasm, you're definitely going to need like an LSTM, and quite a complex one as well.
I mean, if the internet tells us anything, half the people can't even read.
That's what
sarcasm.
I'm saying. You're talking about sarcasm is tough for human brains.
Right.
If you want to translate that to a machine, that's that's high level stuff. That they got their best people working on that right now. Right. That's a note we haven't cracked yet. Getting close, and we've got good technology. I think we've got the means. We just haven't quite found the proper organization.
Common ground.
Yeah,
someone else brought up.
We haven't found a way to organize the pieces yet. To make
I don't know if it was office hours. Someone was saying that they're doing it for like animal communication.
Well, there's people doing everything for everything. Whatever they can get some grant money.
That was me from the
Oh, yeah?
podcast.
Yeah. Oh, there.
All right, on. Explain more.
Okay, so no, it's so cool. They are using machine learning. Obviously, this is way above my head, but they're trying to figure out, like, they're essentially making like a multidimensional map of the language. And what they realize is when they do that with English and they do that with French and they do that with Chinese, like if you would imagine like kind of like clustering, like princess is near queen is near king, but then like where you have like frog is like over there. And like, so basically it's like this multidimensional relationship. But they find that when they're building this map, it's similar across different languages. So they can use that, and I'm sure Google Translate like uses it, but like they can use the structure that they find occurring frequently to translate. So instead, like without looking at German, they can use this structure to figure out, you know, how to say princess in German. And when they are recording the sounds of a lot of animals, they are seeing that some animals, like the more intelligent, like the dolphins, the whales, are actually making a structure that's similar, suggesting that they might have some kind of language. And it's a really cool podcast because they just go into all of like, I don't know, it's really cool. But I don't know, it might be all
there was a research paper written about dolphins to that effect, saying that they had a very
they know definitively that dolphins can communicate. They just don't know to what capacity.
That's what I'm saying. Yeah, there was a paper about that. It was actually to quite a high capacity.
Right.
Almost rivaling us.
Using that structure.
Douglas Adams knew it from the beginning.
What's that? Taylor?
Well, using that structure, they can kind of begin to translate to some extent. And the people that are working on this, they're all it's like a lot of guys from Twitter, like they're like some of the founders of Twitter that are no longer like in Twitter because it's too big of a company now. Mm-hmm. They're like all working on this, and they're trying to do it because it's too long of a story, but it's an awesome podcast.
That's pretty cool. Actually, could you link that? I'm kind of interested, and that kind of fits the topic of NLP, right? That's essentially NLP what they're doing.
Oh,
Just,
yeah.
complex
it's
neural networks.
Most cutting edge NLP.
Yeah.
It's like animal language processing.
Also, I want to point out that the the line between this sort of abstract concept of just a bunch of numbers and the geometrical concept of real dimensional stuff is very thin, right? The boundary is almost non-existent. You could almost directly translate this work that we're doing on words to real geometrical shapes in real 3, 4, 5 dimensional space, right? Like that's a thing that you can do. I just want to point that out, right? And
Yeah, but there's no money in shapes.
No, there isn't, but there is geometrical math that can work in reverse. You can reverse engineer geometrical math to work for words and word vectors, which is exactly what Taylor's talking about. They're using clusters and geometrical mathematical interpretations to work on word vectorization. And that is how they're building this sort of translating software. So at the high level, I'm pretty sure that's what's going on. But yeah, I'd be super interested in seeing more about that.
Yeah, I shared the internet link and then also Spotify, if Spotify is your thing.
Yeah, Spotify's pretty cool. And actually,
Radiolab did one.
Yeah, there's a project that we do that uses NLP. That's a Spotify song suggester, right? Where you take titles of songs and then try to find similar songs using LSTM model.
Yeah, Radiolab just, well, probably like 5 years ago now, did a one on language and the development of language and color, and that all languages pretty much discover colors in a very linear fashion.
Yeah, I have heard. That's interesting.
Yeah. We still don't fully understand how the brain does makes the connections that it does. For instance, there's certain images that are associated with certain smells and vice versa. You got all these sort of weird abstract connections, or seem abstract to us, but we think that they might actually be very fundamental into how we process information. But yeah, the more we learn about, I think, the most sophisticated computer we know about, the more sophisticated our software and machine learning is going to get.
What's that thing called where you like people will associate like what is it?
Synesthesia.
Synesthesia. Yeah.
There's not really explicit boundaries in the brain, so like there's a lot of overlap. Like scent is a really strong memory trigger because the centers for scent are really close to where you store memories.
Mm-hmm. The what is it?
The one person could taste words.
What's the thing that it's called? It's vital for memory storage. Oh my God, hippocampus? No. Is it? Is it the hippocampus?
I don't know actually.
Thalamus? No, yeah, I don't know. But
I forget. Anyways, yeah. So yeah, it's pretty close.
Yeah. Have you guys heard of the Flynn effect?
No.
How
never heard of it.
IQ raises proportionally to like the extent to which a population is developed. And it's really, really interesting, the population's ability to grasp abstract concepts, even like different colors. How like, I don't know, it's very, very interesting. But
it makes sense. You have more resources with which to like work on that kind of stuff when you don't have to worry about if you're going to survive or not, right?
Right. Well, like they go to like primitive societies and all the colors are like named after real world things, like eggshell, sky, like baby, like I don't know, like whatever colors.
Yeah, cafe means brown and it's coffee.
Yeah. Right, things like that. And then and if you show them like different shades of brown, they like don't like it's so weird that they don't grasp it. And then you go to like
their brains don't see it.
Like they're just like, no, it's all the same color.
It's with blue and green. Like blue does not exist to a lot of culture, to less developed cultures.
It's so interesting, and it translates to that ability somehow to be able to categorize colors translates into so many other like capabilities, like mathematical.
They cite Homer and the Iliad, like texts that are from the earlier times do not reference the word blue ever, because it just doesn't happen in nature.
You saying those things are correlative, like some studies on that the perception of color is correlated to these things, or causal?
I think correlated.
Yeah.
Yeah, it's more correlation, not causation.
Science works.
Because you're using sort of this weird that seems more like circumstantial evidence.
Mm-hmm.
Right? You're just kind of like, they don't reference blue, doesn't necessarily mean that they didn't see blue, but it's an indication that
when they do tests, like they'll do tests on more primitive societies, like like some of the Inuit tribes that really didn't get a lot of Western exposure to any of the world.
Modern civilization. Yeah.
What?
Like modern civilization.
Yeah, modern civilization. And like they'll give them a bunch of different shades of like green and blue and tell them, okay, like categorize these. And they really struggle. Like they just don't know.
No, they literally can't see it.
They
Like their
can't
brain
see it.
does not see the color.
And then there's this other interesting test, and it even still happens in modern society. So like in the 1910s and 20s, they would give 5-year-olds vocabulary tests and figure out like, okay, like how good are these kids doing on the vocab? And then in the 80s and 90s, they give the kids the same test, like for 5-year-olds in the 80s and 90s, the same tests. And the kids like vocab words did not get any better with like actual physical words. So like book and dad and house, like that, their vocab performance was the same. But when you ask them about like abstract concepts like law or sad or happy or thinking or the future past, like all these abstract concepts, their performance was greatly increased from the 1910s. So there's something about like modern society that helps us deal with abstract concepts, and that translates into like better performance in a lot of different areas.
Yeah, absolutely. No, I totally agree with that. I think I've seen some research to that effect as well. It's just really funny that you're talking about, you know, like more primitive societies don't see colors. I can't see different shades of red and green.
Yeah, I have a friend that's
That's a real
colorblind. I've
thing.
been thinking about that a lot when we teach at Lambda, that like when you are considering visualization, don't lean really heavily on color coding because, or learn enough about it that you can make it colorblind friendly, because it's really common.
Like most common colors to be colorblind in are red and green. And if
Well,
you show me,
red's the longest wavelength.
yeah, and I've had pictures given to me that were like, these are 6 shades of red, and it literally looks like a solid bar. I can't see the difference.
Red and green are opposite colors.
There's a small portion
Well, you
of
can't
the
see them.
population, specifically
phones are
women,
screwed up.
have the ability to see the deeper or different shades of yellow as well. They've got a 4th cone.
That's craziness. Biological differences.
Well, women have better
Yeah.
olfactory systems than men. That's
Just better,
proven.
you know.
And one of the craziest things about your brain is that you can't actually remember a movie, like a moving image in your brain. Like everybody try to remember a moving image in
Oh,
their
because you
brain.
get freeze frames. Interesting. Very interesting.
Can't.
Uh,
The brain will never produce a moving image.
the
what
do you
mean? You said there's no money.
Can't
in
remember a
shapes.
moving image.
You can
You
remember
only remember
you can remember like a GIF of an image, but it's just a bunch of images that you remembered in close proximity to one another. And then your brain can kind of
You don't see
simulate
them
the idea of it
moving.
moving. But yeah, you don't
You can
actually
hear
see
'em.
images moving. Yeah, I know exactly what you're talking about. You can't. It's a
That always
limitation
freaks
of
me
our biology.
What? You said there's no money in shapes. And we're talking about colors, and it's driving me crazy. The shapes are color. I mean, colors are shapes. Excuse me, because the light, we're receiving the light and we're measuring the wavelengths. But the actual cause of the color is the shape of the material. Is like the microscopic shape of the
It's
material.
the
that
shape
determines
of
what
the
kind
wave
stuff-
of the photon.
Well, what makes it bounce that
What?
way? We're talking about light.
Wait, you're
but
ta-
why do we
Wait,
ascribe
what?
color to the object? Why
The
does
color is the
object have that color?
No, the color. The reason we see something of a color is because it's reflecting that color, and then
No,
it
but
goes through your
what in
eye,
the
then your eye
object-
pops.
What in the object causes it to only reflect
Pigment.
certain wavelengths?
Pigment of the
atoms.
object.
Different
mother-
different
the
atoms
mother-
and molecules reflect
Right.
different
No, yeah, it
wavelengths of
depends.
light.
It depends what wavelength is absorbed.
Yeah,
by
there's
the
a whole
object.
now you're
Sorry,
going
I don't mean to interrupt.
you're like right here on like colors, and then you're getting into physics like real fast. So
No, it's whatever color that is reflected, that's what you see. Everything else that's absorbed is
so
white.
technically, the color you see of any given object is the only color it will not absorb, or the primary color that it won't absorb. There's to some effect, some like don't absorb all colors, but the color that it gives up or reflects the most is the one that your brain registers for that object.
This do I see color better because I don't have melanin in my eyes?
Nope. Absolutely not.
Yeah, maybe not.
You see
No, you see
brightness
your
and
pupils.
lightness better. Brightness or darkness.
My I literally my eyes are essentially albino is what I
You see through
but
the
the
pupil, no?
Wait, what, Taylor?
You
The
see
pupil, you see through. I think you see through it all because the outside will actually absorb light as well, like the color, like where my eyes are blue.
Hmm.
Light still goes through there.
No, the light only goes
The-
through your pupil. It hits the back of your retina, and then your brain processes it, and that's what makes you see things. That's why
use it
Brandon
for-
is colorblind, because the cones in the back of his retina are misfiring.
And you probably know more about photometric than the average
Sounds like he's
person.
got that. Yeah.
Yeah, like he's used
I've been
the
a
word
photographer for a long time.
Right, right. Pigment is what like taught me that concept because I would dye stuff and you cannot keep red dye in things. That's why red bleeds so bad when you wash it. It's something about the shape of the red doesn't want to grab onto things.
No, the reason red is because it's the widest level, more susceptible to UV.
So why are my
That's
eyes?
why- that's
why
why,
are
like,
my
for
eyes more
example-
susceptible to light damage than someone with darker eyes?
It's not light because the way because you're more susceptible to actual quantities of light, not actual difference of light colors.
Right.
The colors has nothing to do with your eye color.
Okay.
It's how much light can be reflected around your eyeball, the quantity.
Oh, okay.
All light is white, right? All light is white.
Yeah. No. Yeah. Physics agrees. All light is technically light. Born of from the same origin. In fact, the same light bouncing around will continue to be the same light that will always be here, and eventually, according to physics, that'll be all that's left. But that's kind of morbid. Anyways, yeah.
Light's awesome.
After this after-hour session, I think I'm more confused than I was beforehand, but now about the spin challenge.
Just about life.
It's about the universe.
Yeah, I think my head hurts a little bit.
Yeah, it's really funny. I'm actually working out a problem that I saw on PBS Spacetime like half a year ago, but just recently got energized in it again. It's the Feynman solution for a single electron universe. So basically, there's this principle that allows for an electron to move both forward and backwards in time, or rather exist in a present and backwards in time. And because all electrons have the exact same mass, which is kind of confusing, right? We haven't really figured out why that's a thing. But there's this postulation that it might be the same electron everywhere.
Don't have a good enough scale.
Yeah. Really difficult to test though, so I'm kind of playing around with that idea. But basically, you can draw an infinite number of Feynman diagrams and explain a single electron going forward or rather backward in time to be every other electron at any given point in time. It's really interesting.
When people go up to space, they technically come back
Later.
in the future.
Oh yeah, in the future. Yeah. But only by several microseconds. And quantum physics has a way of normalizing reality for people when you phase out. Like it's kind of weird to explain that. But the universe has a information retention policy.
Is that because
they're
they're getting further away from gravity, or because they're
No, because they're falling further into gravity. When you bend space and time, you stretch it out. You're technically, like, as you move through space, you're moving through time as well. And the sharper that curve is, like so as you come away from the Earth, you're leaving the gravitational pull. It's actually not affecting you that much because the sun incorporates most of the gravity.
Yeah, well,
in our
gravity
solar
doesn't
system.
affect space-time as much.
But as well, it's one-to-one linear. But anyways, as you move further away from the Earth, its gravitational pull, you're coming out of its gravitational well a little bit. You actually are moving less in time, so you move a little bit faster than everybody else.
You heard like the event horizon, like next to a black hole. If you were to, that's why people, all those movies, they go to these black holes and they're like, oh, they came back and they're only 20 years old.
Because if you went to an event horizon, think movie Interstellar, right? They landed on that planet that's in orbit around a black hole, and every 15 minutes was like 50 years, right? To the outside observer. Why? Because anybody looking at them, their light would take so long to travel back out of that gravitational well to reach you, like that sort of difference, right? And it is basically the embodiment of time travel.
That was
right?
mind blowing, that scene. Oh my gosh.
Yeah, it's really crazy. But yeah, that's actually how it works. If you went that close to a black hole, that's exactly what would happen. To everyone else looking at you, assuming that we had like visual line of sight on you, you would appear to stop moving.
Yep.
your light is just kind of like
And it's
struggling to
technically
get out,
dead.
right? It's taking so long for that light to move, like, but everybody else is moving normal pace.
It's like April.
So you're going back in time. Because it's really interesting, right? If you look at a black hole, you're looking infinitely far into the future, so far that you cannot see anything. There's nothing coming back to you. It's so far ahead that it never makes it back.
That's why I don't know how we understand how old the universe is. How do we know that the light wasn't being pulled back?
That's a complex equation, and we don't know it for sure. Like the universe could be infinite as far as we know, but based on the best guesstimates that we have, looking through a telescope is looking backward in time.
Well, according to the Avengers.
Yeah, but we're seeing a lot of things at the edge of the universe that
I don't actually know. I've never
we're
seen
having
like
harder
any of those
time
movies.
understanding. I don't know if you guys know what a quasar is, right? It's a thing that for a while there, they were like, yeah, that shouldn't exist. But anyways, I digress. I could stay on this topic all night. Listen, it's
Hey,
crazy.
I subscribe to PBS Space Time.
Yeah, so you know then.
You just
already know.
ruined my my book reading. No, I
He's
didn't
about,
even know
he's
about
about
it.
to
until
go
just-
through the whole backlog
Yeah.
of every single video.
Yeah,
Oh, you should.
I
You
could
should.
procrastinate now for a freaking year.
If you go down that rabbit hole is deep, my dude. Just be aware.
I started early. I'm lucky.
Speaking of that, though,
Yeah, there you go. There you go. I'm up
baby's
to
gonna
date.
have me up here in 6 hours. So
That's how it is. Yeah. So this was pretty fun. Hopefully everyone's feeling a little bit looser, right? A little bit ready for the sprint challenge tomorrow. Like I said, the stuff we covered today should be 90% of the sprint challenge, right? Try not to get stuck on processing steps like working through pandas and stuff like that. Get your notes set up, get some working examples of code. That way when you're ready to jump in, you don't get stuck on any of those steps, because those are the ones that'll get you. Watch it. It won't be tokenization. It'll be freaking, how do I get a pandas list? Or, how do I get a list of stuff into pandas? Like, that's the crazy stuff that'll choke you up. All right. Cool. Well, for everyone who's interested, yes, hop in before hours. I'll see about doing some topic analysis stuff.
Is
All
it
right.
2 hours before class or warm up?
Yeah, it's 6 to 8 a.m. instead of 6 to 8 p.m. Makes sense. So if you're Eastern time, it would be like
9 a.m.
no 6, 7, 8, 9. Yeah, 9 a.m. It's like 9 to 10 or 9 to 11. Yeah. Just 2 hours. All right, cool guys. Well, I'll see you all tomorrow morning.
I think it might be 9:38.
Ciao, guys. Good chat.
Later.
Good luck.